Honors Geometry on Supertide Tuesday, the 13th of this fine month of October. SWBA, y'all will be able to solve statements about angles, section 2.8, which is our very last section of this chapter, okay? They don't go away. Okay. So we have an angle proofs reference. Have we seen these properties of quality before? Yes. Have we seen these properties of congruence? No. The answer to both is yes. If you say no, I'm sorry, okay? I don't know how to help you at this point, okay? Definition of congruence. We've seen this definition for segments, saying that, hey, if two segments are have the same measure, they're congruent, or vice versa, right? Same thing with angles. Two measures of angles are congruent. The angles or two measures of angles are equal. The angles are congruent. Arrow goes both ways, so it can go the other direction. Does that make sense? Yes. Basically the same thing, but with angles instead of segments. And we can call it the same thing, definition of congruence. You don't have to say definition of congruent angles, definition of congruent segments. You can just say definition of congruence. Gucci? Gucci. Definition of angle bisector. We have another definition of angle bisector. An angle bisector divides an angle into two equal parts. Does that sound familiar? Yeah. Bisecting by two sections, okay? Divides it into two equal parts. Definition of complementary angles. If they're complementary, their sum is 90. It goes both directions. If the sum is 90, they're complementary. Remember that poster right by Aiden? Those complementary angles. Aiden, can you read that poster for me?
Right behind you.
Jacob, can you read that poster for me?
I liked it. You're a good friend. I like the way you always help me.
Oh, they're complimenting each other, guys, because they're complementary angles and they add up to 90 degrees. How sweet. Okay? There you go. I don't know what you're talking about. Definition of supplementary angles. If two things are supplementary, they add up to 180 degrees. If they add to 180, they're supplementary. Vice versa. We've seen this before, right? Yeah. Okay. These are our definitions. We defined these beforehand. Definition of perpendicular. What's it mean to be perpendicular? Perpendicular lines form right angles. If two lines form right angles, they're perpendicular. Definition goes both directions. Definition of a right angle. If it's a right angle, the measure is 90 degrees. If the measure is 90 degrees, it's a right angle. Definitions go both directions. Does that make sense? Yes.
What's the difference between the definition of perpendicular and right angle?
Yes. This one, they lead to one another. So the definition of perpendicular says, hey, if they're perpendiculars, they form right angles. So you could definition of right angle, if it's a right angle, it's 90 degrees. So you really could kind of use like the law of syllogism to say, hey, if they are perpendicular lines, they form 90-degree angles, right? You could actually technically use the law of syllogism to link the two, but they're separate statements. Is that what you're going to say? I knew it. I love it. Okay. Now notice, one thing I said before with definitions is if you have a lot of words to math or math to words, here's where we're really going to see that, okay? Here's where we're really going to see that with these bottom 5 definitions, okay? And we'll see that in a bit here. Okay, more references. Postulates. Angle addition postulate. It's pretty similar to our segment addition postulate. You had two parts of an angle, you get the big angle. Does that make sense? Not at all. Sarcasm? Perfect. Okay. I just had to double check, like I assume, because it's you, but like I had to make sure. Okay. Vertical angles theorem. If two angles are vertical, then they're congruent. You guys remember what vertical angles are? Okay.
Like this.
No. Okay? It's where they make an X. It's the ones that are opposite each other. So it'd be like this angle and this angle. Okay, they're opposite on the X. Okay? They share that vertex. Vertical angles are 100% time congruent. Vertical angles theorem says that. Does it make sense that the vertical angles theorem would deal with vertical angles being congruent?
No.
No? Doesn't make sense at all? I think so.
0 bits.
Okay, 0 bits. Okay? Complement theorem. If two angles form a right angle, then they are complementary. If two angles form a right angle, it means they have to be complementary. If they form a right angle, they have to add up to 90, right?
Yes.
So that's what this is saying. So if they add up to 90, they're complementary. So that's their complement theorem. Supplement theorem, same thing, except for if they form a linear pair, then they have to be supplementary. What does a linear pair add up to? 180. Does that make sense? I think so. And do we see the word complement and complement theorem? Do we see the word supplement and supplement theorem? Yeah. These are hints for us. We will see the words in a lot of what we're doing. Congruent complements theorem. if angle A is complementary to angle B and angle C, or an angle C is complementary to angle B, excuse me, then angle A is is congruent to angle C. My goodness, I botched that. Okay, let me draw this out. If angle A adds up with angle B to be complementary, okay, instead of drawing that, I'm actually going to write it out. So give me a measure for angle A less than 90. 34.
Wow.
What would measure of angle B have to be in order to be complementary with that?
56.
Okay, 56 degrees. Okay, now we're told angle C is also complementary to angle B. So what does angle C have to be?
34.
34 degrees. So what do we know about angles A and angle C?
They're equal.
They're equal in measure, and so the angles are congruent. That's what the congruent complement's saying. Does that make sense? Like there's literally no other way it could be besides those being equal in measure and thus congruent. As long as we have this top set up to where angle A and C are both complementary to the same angle, they have to be congruent to each other. For them to be complementary to the same angle, they have to be congruent to each other. This one says the same thing, congruent supplements theorem. If two things are supplementary to the same third angle, they're congruent to each other. Same idea, but with just different numbers added to 180 instead of 90.
Nice.
Where are we at with this?
Sort of. Okay.
Okay, that doesn't help. Okay.
Wait, you guys
Okay.
fall asleep with your eyes closed, like weirdos?
Okay. Okay. Dominic, what don't you understand? Okay. How about we use them and try and see if they kind of start clicking as we use them, maybe, okay? That might help. Okay, Aiden, does that sound good to you too? Okay. Practice! Okay. Justify each of the following statements using a definition, theorem, or postulate. If angle A is a right angle, then the measure of angle A is equal to 90 degrees. So we start out with words. Angle A is a right angle. Then we transition to math. This measure of angle A is equal to 90 degrees. You might not think that's math, but I disagree. We see an equal sign. We have an equation there. We go from words to math. When we go to words to math or math to words, what's the hint for? Definition? So I heard it. Definition of
Right angle.
right angle. Okay, here's how we can help us out. What word does it say in there? What two words do we see? Right angle. Okay, so when it goes to words math, we look at what words are used. That can help us. And also, we can think definition means what does something mean. So what does it mean to be a right angle? It means that it's 90 degrees. Okay? Number 2, if x is supplementary to angle y and angle x is supplementary to angle z, then angle y is congruent to angle z. So two things are supplementary to the same angle y, or same angle x, so now they're congruent to each other. Liam.
Congruent supplements theorem.
Yeah, congruent supplements theorem. And notice how I shorten that up. Okay, congruent sup theorem. So you're trying to slide in someone's DMs. Sup. Okay. Thum, thum, thum. Thum, 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 thum. Okay, congruent supplements theorem. Number 3. If angle 1 and angle 2 are set up like so, then angle 1 is congruent to angle 2. What kind of angles do we think angle 1 and angle 2 are?
Vertical angle.
Vertical angles. So if those are vertical angles, then they're congruent. What tells us that?
They're vertical.
The vertical angles theorem. The vertical angles theorem says, hey, if they're vertical angles, they're congruent. We're not coming up with and calling it something else. We're just saying, hey, if they're vertical angles, a theorem's going to say that they're vertical angles. Number 4, if measure of angle P and measure of angle Q equals 90 degrees, then those angles are complementary. It's going to be a definition because we're going from math to words. We're going from math to words of complementary. Definition of complementary. Okay? In this case, actually, definition of complementary angles, I should say. Excuse me. Definition of complementary angles. Okay? Dominic.
What's the difference between theorems and properties?
Yes. So properties and theorems. Theorem is something that we can prove. Property is more something that we kind of discover to be true about something. Oh, let me think about it. Let me think about an example I can use to explain that. So like the addition property of equality is saying that, hey, if we add the same thing to both sides of an equation, it stays true. That's something that we more kind of observed to happen, of saying, hey, this is actually a property, it holds true all the time, and we just more observed it to happen. Whereas a theorem was something that was gone through and it was actually proven. So like on number 3, like you can take a series of a bunch of different vertical angles, and over time you say, this is true every single time. It is proven to be true. We can't prove it to be false. I don't know if that makes sense or not. Although I mean, you could technically call the addition one to be a theorem as well, but you don't need to prove it. It's more of one that you're accepting as true. Max.
So none of this is like on top of anything, really. But
Okay, thanks for that heads up.
For like the vertical angles, does it always have to like be like an X, or can it be more like a T? Or in order to be classified as vertical angle?
Like that?
No, like lowercase one.
So could they just be
That's an
facing
X
this?
sideways.
Could they be facing this direction?
Yeah.
Yeah, they could be facing that direction. Yep. So if you just turn it to the side, go, okay, then you'd have that. That make sense? Okay, great question. Okay, number 5. If angle M and angle N form a right angle, then angle M and angle N are complementary. If they form a right angle, then they're complementary. Well, are we going words to math or math to words?
Oh.
No, so probably not definition, so we can rule those out. Okay, it is the complement theorem.
I said that.
I said it.
If we have a right angle, two things make a right angle, then those have to be complementary. That's our complement theorem. Okay? Gucci?
Gucci.
Okay. Okay, getting there. Okay. Is it making more sense than before?
No.
That's a win. Okay, maybe we're, instead of like a nickel, we're at like a dime. Okay? More sense. Okay? Thank you, Kelly. I appreciate the giggle. Was that you? Okay, I thought so. Okay. All right, given. Okay, we're given that line M and line L intersect like so, and angle 1 is right in there. So we're told, hey, if line L is perpendicular to line M, then angle 1 is a right angle. If line L is perpendicular to line M, then angle 1 is a right angle. Now, this might not seem like it, but this is actually going math to words. This is actually going math to words, okay? The first part we're going to say is math. L is perpendicular to line M. Line L is perpendicular to line M. Then angle 1 is a right angle. Now, it's the definition. Definition of perpendicular. If two things are perpendicular, two lines are perpendicular, they form right angles. That's what it means for them to be perpendicular. Well, and they have opposite reciprocal slope, but we're not talking about that right now. Number 7. If angle W and angle X are supplementary, then those two angles add up to 180 degrees. Definition of supplementary angles. This is a definition. We're going from words to a math equation. And we're saying that's what it means to be supplementary. Is they add up to 180 degrees. Depth of subangles. Number 8, or Nate. If angle L is complementary to angle M, and angle N is complementary to angle M, so they're both complement to angle, so both angle L and angle N are complementary to angle M, then angle L is congruent to angle N. Congruent complement theorem. A good way to think about this, guys, is it says congruent complements. So complements is plural. Okay? And how many different times do we see the word complementary?
2.
Twice. And plural means more than one. So we see complementary more than twice, so it's a good hint that it's going to be complementary complements. Okay? Yes, there's 0. Okay, number 9. 9. If angle A and angle B form a linear pair, then those angles are supplementary. If angle A and angle B form a linear pair, then they're supplementary. What? Supplementary theorem. Supplement theorem.
Subthum.
Subthum. Okay, supplementary theorem. 10. If angle N and angle P are complementary, then their measures equal 90. The measures will add up to be 90. So we went from words to math, didn't we?
Yep.
So what's that a hint for?
The definition.
Definition. Are we seeing this words and math thing a lot more now?
Yes.
Okay, definition of complementary angles. If you look back at, okay, what are we talking about? What words do we see? We see the word complement in there. Okay. Number 11, we're given this diagram, and we're told, okay, measure of angle JKM plus the measure of angle MKL equals the measure of angle JKL. What's happening there? We're adding two small parts to get the big part, right? So it is the angle addition postulate. Nice part with angles is you can always just do the angle symbol instead of writing out the word if you want to. Number 12. If measure of angle R is equal to the measure of angle S, then those two angles are congruent. Definition of congruence. If two measures are the same, then they're congruent. Or vice versa. If two things are congruent, their measures are equal. Regardless of whether it's segments or angles, we don't really care. It's still definition of congruence. Questions on that? Okay. Guess what, guys? You guys ready? You guys ready? You guys ready? You guys ready? We got more proofs! Let's go. Okay. We're going to go through a few of these. Okay, we're not going to go through all of them. We're going to go through a few of them, okay? Okay?
It's 11 out of 10.
So, we're given a word bank on this one, aren't we?
Yeah.
Okay? And we have at least one freebie. Okay? So we're given the angle PQR is a right angle. What could we draw on our picture to show that?
The square.
The little box thing, right? Okay, let's do that. Drawing on our pictures is something I really advocate, guys. It can really help us a lot. Okay? And especially a lot of us are very visual. Okay? And that can really help. Angle PQR is a right angle. Well, how do we know that?
Because it says.
Because it says given. Okay? So now we're told it went from being a right angle to now the measure is 90 degrees. So we went from words to math, didn't we? Definition of it being a right angle. Now, how can we know it's a right angle versus complementary angles?
Because it's only one.
Okay, it's only one angle. That's a good point. Okay. Another reason we could say is, well, it says it's a right angle. So we're going to use the fact that it is a right angle to say it's 90 degrees. Now we're told the measure of angle PQS plus the measure of angle SQR equals the measure of angle PQR. If you look up at our picture, what's happening there with those angles?
They're getting added together.
Those two small ones are getting added together to be the big one, right? So what tells us we can do that?
Angle addition.
Angle addition postulate. It's very similar to the segment addition postulate, right?
Yes.
Except where it's with angles. So we say angle instead of segment. Okay? Number 4, measure of angle PQS plus the measure of angle SQR equals 90 degrees.
Transitive.
It's our transitive. We could use substitution. It's just not an option here. We could use substitution as long as you clarify what that is. We're saying, hey, if we combine steps 2 and 3, both say, measure of angle PQR is equal to both 90 degrees as well as these two measures being added together, so they're equal to each other. Okay, Levi?
So I have a question. So
Yes.
On the test, would it be a word bank for each problem? Or
On the test, it's going to be a very general word bank. Yep. Great question. Okay. On number 5, we went from the adding the measures to get 90. So we went from math into words with those being complementary. Math to words is a hint that we're doing a what? Definition. In this case, definition of complementary angles. We have two angles adding together to be 90 degrees. So they are complementary. Okay, it is. I charged it. Yes. And now my pencil is at 34%. It charges rather quickly, which is nice. Okay. Questions on that first one? Is this making more or less sense than the segment proofs did right away?
I don't know.
Yeah.
Okay, maybe a little bit more. Okay.
It's way more because there's a definition.
Maybe more because of what? Because we already learned a lot of these stuff. So we struggled through the first part So now we're starting to get a little bit more. We'll continue practicing. We'll get it a little bit more, and so on and so forth, okay?
I'm gonna add stuff to it.
Yo, it always gets harder. You know math. Okay? Jacob, I know you didn't hear anything else, but just that part is true, right? You know it's going to get harder. It's math. Okay? It doesn't just get easier or stay the same. It always ramps up. Okay? Let's look at number 2. Okay, probably. Angle 2 is congruent to angle 3, and angle 1 and 2 form a linear pair. Well, our first statement, what's our reasoning? It's given. Now, I said before, it's good for us to mark our information. So how can I mark the angle 2 and angle 3 are congruent? The little arc bubble thingy. Okay? Now, are we given another piece of information?
Yes.
Now, I advocated earlier that it can be good to write it down right away so we don't forget it. Okay? So that'd be statement 3 is given to us. So reason 3 is that it's given. Now, we don't have a way to draw out that it's a linear pair. But let's go back now and do statement 1 to statement 2. After we made sure we called everything given, because sometimes I see people hung up on the fact that the givens are separated. Okay? So it's good just to fill it in right away so we don't lose track. So 1 to 2, what happens? Went from them being congruent to the measure equal. Definition of congruence tells us that we can do that. If two things are congruent, their measurements are equal. So now statement 3, we're told that they're form a linear pair. So from statement 3, since we're given some information, we just brought this in, we're probably going to use it right away. So now they're supplementary. If they form a linear pair, they're supplementary. Supplement theorem. Very good, you two. Sup them. So I got Hannah. I was like, hey, sup them. Okay, just kidding. It's true, it's true. Okay, that was Gage's joke, guys.
Yeah.
That was Gage's joke. Okay, now everyone knows, okay? Angle 1 and angle 2, their measures add up to be 180 degrees. We went from words to math. Words to math. Definition of supplementary. Definition of supplementary angles, excuse me. So now, wait. On 5 to 6, did we see... It is substitution. What are we substituting? Yeah, we're substituting measure of angle 2 for the measure of angle 3. Back from step 2. Came back. Okay. So now we went math to words. So probably definition, and it is definition of supplementary angles. If these two angles add together to be 180 degrees, they are in fact supplementary. Now, if we had just looked at this picture originally, could we have necessarily known right away that 1 and 3 would be supplementary? Maybe not. Okay? But we were able to go through systematically and say, well, based on this given information, we can get there. We can prove this to be true. So now we know it's true. Okay? Questions on that one? Okay, we're going to skip 3. We're going to do 4. Okay, I want us to try 4. Okay? What? We'll see.
I'm just crying. My contact keeps acting up.
Oh.
So, I keep just crying.
If you get
Man, I thought I was going to get raised, but you're not even crying because of math. Okay, I want you to pretend. Okay, when somebody asks you later, why were you crying?
Mr. Kraft.
Perfect, okay. Yep, Mr. Castleman. You can cry, guys. Yes, okay. Yes, I am not actually holding people for ransom or making people cry. Okay, now that we can continue on after that disclaimer in the video, okay? If anybody else watches, it's going to be mad random, okay? Anyway, so we're given the fact that ray BE bisects angle ABD, and also that ray BD bisects angle ABC, or EBC, excuse me. Oof. So what's our first reason?
Given.
Given. Do we have another given?
Yes, number 3.
Yeah, number 3.
Is always number 3 and number 1?
Nope.
What's the first one? Second.
I guess it could be, but it probably will never.
What's the second definition of angle bisecting?
It is the definition of angle bisector. We went from words, this bisects this. That's a sentence. Okay, even if we don't think it is. To math, that these measures are congruent. These angles are congruent. And bisects means it cuts it in half, right? So if ray BE bisects this angle ABD, well then it should make those congruent. Does that make sense? That's something we did back in chapter 1. Okay? Now, from 3 to 4, are we doing the same thing, really?
Yeah.
Just with different rays. Or a different ray at a different angle. Once again, I like to draw it up in my picture because sometimes it can help us see it. So, angle EBD is congruent to angle DBC. Now, I already have one arc on an angle EBD. So, how many arcs do I need on angle DBC? Uno. One. In English. So, now in my picture, can I see that what I'm trying to prove should be correct? Or is correct? The angle ABE is congruent to angle DBC?
Yes.
Okay. And what property can get us there?
Transitive.
Transitive. Could we also use substitution?
Yes.
You betcha, as long as we clarify.
Wouldn't it be angle EBD is congruent to
Like,
angle?
we can do this one all
Sure. Or you could say it's congruent to DBC, either
Are
one.
they all congruent to each other?
Yes. So as long as you put, honestly, either
Like,
number
that's
2
like
or number 4 in there for what you're saying you're substituting, it can be accurate. Questions on 4? Oh, you guys crack me up. All right. How many guys try number 5 on your own?
That's impossible. But you can give us the one with extra.
Okay. So what's our first reason? Good. Now I'm going to advocate for drawing this in our picture that angle RSU is in fact congruent to angle VST. Now we're told that those, if they're congruent, their measures are equal. What tells us that? The definition of congruence. Now, measure of angle RSU plus the measure of angle USV equals measure of angle RSV. What tells us that can be the thing? The angle addition postulate. On 3 or 4? Oh, I'm sorry. I misspoke then. I meant 4 and 5 then. I'm sorry. On number 4, measure of angle VST plus measure of angle USV equals the measure of angle UST. What says that can be a thing? Angle addition postulate. We can add those 2 parts again to get the whole thing. Now, is that the same thing as happening on 5? No, if you look up at the picture, that's not what's happening. What's happening on 5?
Substitution.
We're substituting.
Problem.
What am I substituting for what?
Measure angle RSU equals measure angle VST.
Yeah.
Number 2, please.
Back from number 2, we're substituting that back in, and we're going to rewrite number 4, but instead of measure angle VST, we're going to put measure angle RSU, because they're the same thing, according to step 2. So now, how could I get from 5 to 6? Transitive property, by using which 2 statements, just so we're clear. You don't have to write it, but statements 4 and 5? No. Statements 5 and 3? 3 and 5? Okay. Measuring angle RSV and the measuring angle UST, both equal to the same 2 angles being added together?
Yes.
Okay. So now we went from the measures being equal to them being congruent.
F angle.
Definition of congruence. Questions on number 5? Aiden?
number 4 and 5.
No. We cannot switch around number 4 and 5 because this one, angle VST plus the measure angle USV, does in fact add up to be the measure angle UST by the segment addition postulate. But if we look down here, measure of angle RSU plus USV, RSU and USV, that does not give us the measure of angle U to S to T. Because those 2 parts don't make this whole. Does that make sense? Or no?
0 sense.
Aiden, does that make sense?
No,
Okay,
it's-
what-
Oh, wait, never mind.
Does it make sense now?
Yeah, I looked at it wrong.
Okay, okay.
The highest grade teacher is 5.
Bill.
Okay, this is an extremely good question. Can you
7.
Switch 3 and 4?
Yes, you can, but only You can only do it if you breathe in through your nose while you do it, and then hold your breath until you complete doing it, and then exhale after you're done through your mouth.
Got it.
Okay? That's the only way you can do it.
Anyway.
Wow.
Make double down.
Pretty complicated.
Okay.
That's some hard stuff.
We're going to skip 6. Okay?
We're almost to the front.
We're almost to the front. We're almost done. Okay. Let's practice
I don't wanna take a test.
number
I don't want to take a test.
7.
I never thought we'd finish this.
I know, right? This bad stack of notes is almost done. It's almost conquered. Okay? Number 7. Okay? How about this, actually? I want you guys to choose between 7, 8, and 9, and we'll do one of them. Okay? So take a second to look them over. Voices off. Voices off. Take a second to look them over. Raise your hand for number 7. Hands down, which is none. Raise your hand for number 8.
He's gonna
Okay.
make us do the other ones as homework.
No, he's not.
Okay? Hands down. Hands up for number 9.
9
Okay,
will help us
number 8 won it by quite a bit. That means a lot of people didn't vote. Number 8 it is. Angle 1 and angle 2 form a linear pair. That is given to us. Now wait, in number 3, do we see another given? So what do we think probably goes there, guys?
Measure angle 2 plus the measure angle 3 equals 180.
Degrees.
Degrees, okay? Now in angle 1, number 1 and number 2, we went from given to the supplement theorem. What does the supplement theorem say?
180.
Okay, if two things form a linear pair, that they are that they're supplementary. So angle 1 and angle 2 are supplementary.
Oh, I knew that. Sure, buddy.
Okay, so we went from 3 to 4. We use the definition of supplementary angles. A definition would go words to math or math to words. Well, were we just given math or words? Math, what are we probably going to?
Words.
Words, okay. And what word are we probably going to include in there somewhere? Supplementary, okay. So if measure angle 2 and measure angle 3 out to 180, what do we know about angle 2 and angle 3?
They're congruent. No. They're linear.
Angle 2 and angle 3 are
Vertical.
supplementary. Is that true? If they add up to 180 degrees, are they supplementary? Yes, that is true. That's what supplementary means. It's literally the definition. So now,
What's the difference between the supplement theorem and angles?
yeah, great question. Supplement theorem says if they form a linear pair, they're supplementary. Definition says if they add up to 180, they're supplementary, or if they're supplementary, they add up to 180. Does that make more sense, Liam? Okay, good question. Now on number 5, we're now told that angle 1 is congruent to angle 3. We don't see. Do we see angle 1 and angle 3 together anywhere?
No.
Okay, but what do we see 2 of? We see angle 1 and angle 2 are supplementary. We see angle 2 and angle 3 are supplementary. So are angle 1 and angle 3 both supplementary with angle 2?
Yes.
And now they're congruent to each other. So what happens when we see these supplements twice?
Trans.
Double.
Sim.
Definition of
Subtraction.
I'm not good at that.
Congruent. Supplement. Congruent supplement. I said that.
Congruent supplements theorem. The congruent supplements theorem says, hey, if two angles are supplementary to the same third angle, they're congruent to each other. We can always go back to our reference page at the start of the section to help to know that, right? Okay, that's a hint. If you go back to your set reference page during this, that might help you understand. Okay? Because that's exactly what it says for the congruent supplements theorem is, hey, if these two angles are supplementary, if this is supplementary this is supplementary this, those are congruent. Max.
So if you have linear pair, then we'll always, if you add them together, then we'll always get 180 degrees.
Yes.
Can we just please do 9? Like, I'm still kind of confused.
Okay. Do you want me to walk through 9?
Sure.
Okay. I'm getting a request for it.
Yeah, that was
Okay. So our first one is given that segment AB is perpendicular to segment BC. And I'm going to write that in our picture by giving it a right angle. Now we're given another given later on, aren't we? Where at?
7.
The second to last one. Dominic, it happened.
No.
No way.
That was me.
Okay? I don't think so.
It wasn't. I don't think
Okay, so from number 1 to number 2, we went from those two segments being perpendicular, and now we know angle ABC is a right angle. So we went from math to words. We went from math to words. Definition of perpendicular. That's what it means for them being perpendicular. Perpendicular segments or lines form right angles. Yes, it's like an upside down T. It looks like the top half of a perpendicular set of lines.
Can I just do def with perp?
Yes. As long as you spell it P-E-R-P rather than P-U-R-P like purple.
Yes.
Now we have definition of right angle. So we add words. So what are we probably going to have next?
Right angle equals
Numbers.
90 degrees.
Math. So whatever right angle is 90 degrees. So what angle equals 90 degrees?
ABC.
The measure of angle ABC equals 90 degrees. That's what it means to be a right angle.
It does.
Yes.
90.
So now we have the measure of angle 1 plus the measure of angle 3 equals the measure of angle ABC. Well, that doesn't look like it directly follows from 1, 2, or 3. But do we see that happening in the picture anywhere? Angle 1 and angle 3 up here at the top add up to angle ABC.
Yeah.
What could that be?
Angle
Angle addition function. Very good, Kaya. Because we're adding those two smaller angles to get the bigger angle, angle ABC. So we're adding two angles that are next to each other to get the angle that they form together. If we say if I'm going to take this angle 1, this angle 3, I'm going to get the whole angle ABC. Now we're saying measure angle 1 plus the measure angle 3 equals 90 degrees. Okay? Substitution or transitive. Okay? We could call it either one. If we're saying substitution, I want us to clarify what we're substituting. Transitive property. Step 3, we're told measure of angle ABC equals 90 degrees. Step 4, we're told that measure of angle ABC is equal to measure of angle 1 plus measure of angle 3. Well, now we cut out measure of angle ABC, and they're equal to each other. Does that make sense? How that would be transitive? Ireland looked mad confused. Okay. So now, on 6, we said we're using definition of complementary angles. So we had math in the previous one. So what are we probably going to go to if we're using definition? Words. So if measure of angle 1 and measure of angle 3 equal 90 degrees, what do we know about those two angles? They're complementary. So angle 1 and angle 3 are complementary. So now on statement 6 and 7, we're told that angle 1 is complementary with angle 3, angle 2 is complementary with angle 3, so angle 1 and 2 are both complementary with angle 3, and now angle 1 is congruent to angle 2.
Isn't it? Because it's double comp.
It's double comp?
Theorem.
Congruent.
Congruent complements theorem, because it's the double comp, so it's going to be where we see complements being plural. Congruent complements theorem. Saying, hey, if two angles are complementary to the same third angle, that means they're congruent to each other. Okay? That's very similar to how we ended our last one, right? But last one was the supplements, this one was complements. Okay, Bill.
How much will my grade go down if I fail this?
Depending on how much you fail it by. Okay, any other questions? Okay, I'm going to get out the homework now, okay? I'm going to have us struggle through some of these on this, just like we kind of did with the segments, but I feel like you guys are understanding it increasingly more, okay? Which is encouraging to see, okay?